Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at strong acid and strong base in terms of pH and POH. But first, let's review what is strong acid and bases. Strong acid and strong bases dissociate completely into ions in water. For example, let's look at this one here. We have HCl, okay? When that is dissociate in water, it will have H plus and Cl minus, and both of them are in aqueous states right there. As you can see here, the ions produced from those strong base and acid are strong electrolyte. That is, they conduct electricity. And one thing we have to remember that we are now talking about equilibrium constant, it would have a very large values. That values is usually greater than 1. So a very large values of K, okay? So keep that in mind. K is equilibrium constant. Of course, I have different values here, but it doesn't really matter because what we want to focus on right here. Most cases, they will have KSP, okay? When it comes to strong acid and strong base, there are very few of them, and you have to memorize them. Here you can see that we have HCl, HBr, and HI right there. This is coming from group 7A right there, right? Except for the F. So as you can see, you have to memorize this. You have to memorize this strong acid. If you don't memorize this, and you're going to have a very difficult time. The same thing with the base. How you see group 1A right there. See it right there, and then group 2A. Okay, as you can see there, those are strong acid and strong base, and you have to memorize them. You have to be familiar with them, because when we're solving problem with strong acid and strong base is very different than solving problem with weak acid and weak base. It would completely change everything. So now that you have taken the time to review those names and memorize them a little bit, we are going to look at in terms of pH and POH. First thing first, pH plus POH equal to 14. And you see those P right there? That P in mathematical term is equal to negative log with the base of 10 right there. So it's what that P represent. Every time you see P of anything is negative log of whatever that is, okay? So for example, we have pH is the negative log of, again, with the base of 10, but we don't really write it. This is the concentration right here. That's a concentration of H, and POH is the negative log of the concentration of OH. Now, one thing we have to be very careful when it comes to pH and POH is that this one can only be solved with the base of, or base with OH, okay? And this one is for acid with H, okay? We can solve that mathematically using the chemical formula that's given to us. If it's not, you can see right there, right? All the strong acid has the H, that right there, and all the strong base has the OH. See that? If it doesn't have it, you cannot solve using pH and POH directly, okay? And one thing we are going to work with is that how can we solve for the concentration? And I already write down the formula for you right there already. But I'm going to show you how you can determine from here to get that, okay? So let's look at pH right here, which we know is negative log of H, okay? Our goal is to solve for that. So one thing you're going to do is you bring this over, so you have negative pH, and this process works for POH as well. So negative log of, okay, so here we have negative pH equal log of H. So how do we cancel that log? By definition, you see right there, B to the log of B, and we know this is 10 already, right? So therefore, what's B? B is, the base is 10, so if I take 10 to the power of that, both sides, now this cancels out equal to 1. So what we have right here is just H right there. See that? So it doesn't matter if this is OH or not. It works the same way. So the concentration is 10 to the power of pH. And guess what POH is going to be? 10 to the power of negative POH. There you go. See that? So easy, isn't it? And of course, you don't really use the caret symbol for now, but I just want to show to you, just to represent that it is an exponent power, okay? So for now, you can write like this, 10 negative POH, there you go, or 10 negative pH. Just make sure this is an exponent, okay? So be careful with that. Now, if you are given pH and POH, can you decrease the values of pH and POH? And one obvious thing to do is by diluting with water, basically adding more water to it, okay? So if they ask you, how can you decrease pH or POH? You just add water. Again, is talking about the concentration. So if you add more water, the concentration decrease. Now we are going to solve a problem with pH and POH. So in this case, estimate. I'm going to use the word calculate. Okay. Now a lot of time on your AP test, you are going to have to estimate because it's a multiple choice. If it's not, you have to really use the mathematical representation behind it. But before we do anything, you see that right there? We have pH, and this right here is a decimal, but we are working with concentration in terms of times 10 to the power something. So one thing when it comes to estimation, you have to put this in terms of 10 to the power. So basically we have 1 times 10 to the power of what? In this case, 1, 2. Okay, so it's -2. See that? So this is equivalent to that. Okay, because if we go back to right here, see that right there? Using that shortcut right here, using that rules right here for log, you can actually estimate it very easily. So let me show you how to do that. So here we have pH equal to negative log, okay? And instead of using that, we're using this right here, 1 times 10 to the -2. We don't really care about the 1 part. But basically what happened here, if the base are the same, so you have this is also 10 to the 10, and we have the negative right here. Look what happened, the answer is going to be. It's just going to be 2. See that? We don't have to do anything. So a lot of time when it's on your AP test question, you have to do this basic math. Using this trick, right? Negative log of the same base and that to the power of a number is equal to that particular number. So keep that in mind. So the answer in this case is 2. And I'm going to prove that to you using decimal calculator right here. So what we have here is what? Negative log. Okay. And what do we have? Go back to main. Okay. 0.01. Okay. So assume that we don't use this. We use that. Parenthesis. There you go. Look at that. Beautiful, isn't it? So get used to convert from decimal to that, because without that you could not able to estimate it. And that's what a lot of your AP questions are going to be about. In this case, calculate. Let's look at the next example. Calculate the pH of this one right here. So again, convert it 1 times 10 to the -2. Now this will get a little bit tricky, okay? But before we do any conversion, this one is really hard to estimate, so we're not going to do it. So we have pH equal to negative log of H, okay? So what is this concentration going to be? But here's the tricky part. You see that 2 right there? That 2 right there will change whatever the concentration of H is going to be. You have to double it. So that means the concentration of H is equal to 2 times the concentration of H2SO4. Because in 1 mole of HOSO4, there are 2 of H right there. See that? So we have to multiply. So let's plug it in. So 2 times 1 of that right now is 0.01. So what's that going to equal to? 0.02. See that? So don't get tricked by that. This is extremely very important. Make sure you pay attention to the subscript. That will change everything, okay? Now we just plug it in. So negative log of 0.02. For now, I'm not going to do the estimation. It's too hard. But if you estimate it, it will be about what? 1.1 to 2, okay? So let's check it out with a decimal calculator. Because if I look at this right here, okay, let's look at this. Let's do an estimation behind it. Negative log of 2 times 10 to the -2. I cannot really do the estimation part here, but I can do that right there, okay? But I know for sure this part right there is 2 something. I don't know what's the log of 2 going to be. But I know it's going to be somewhere near 2. So let's look at this calculator. So we have negative log of 0.02. There you go, 1.69. Isn't that nice? So we have 1.698, which is equivalent to 1.70. Okay? See that? So even though we don't really use the calculator, we can estimate it somewhere near 2 because of that part right there. Now let's try the most challenging question of them all. And that is, how do you calculate the pH when there is a base? And especially this base has a 2 to it. So this is where it gets really tricky. We learned that pH and pOH equal to 14. We know that for sure. Okay, so let's do that. pH plus pOH equal to 14. For now, we're not going to do the estimation. That's too difficult. We have to worry about the concentration of OH, okay? But before we do that, let's isolate pH equal to 14 minus pOH, right? Basic math. Bring this over here. Okay? So let's look at this right here. We know there are two of them, so that means the concentration of OH is equal to 2 times the concentration of BaOH2 because of that subscript right there. So in this case, 2 times, we know that concentration is right there, 0.10. Okay, so we have 0.20. Okay, that's easy so far, right? Now all I have to do is just plug it in. pH equal to 14. What is P equal to? Negative log. Ooh, before we do that, minus, so it's minus log. Well, this is a negative log, okay? So keep that in mind. Negative log of 0.2. What is that going to equal to? Let's use a calculator. Let's use a calculator. 14. Let's use a calculator. Before we use a calculator, let's simplify this. Before we use a calculator, let's simplify this. Minus and minus, that's equal to plus. Okay? So we have 14 plus log of 0.2. Now let's plug it in. 14. Let's clear that. 14 plus log of 0.2. And the answer is 13.30. So in this case, the pH is 13.30. And there you go. Isn't that nice? Now, how would I calculate the pOH for this? Just to move on a little bit. If I want to solve for the pOH, okay? So we know that this is 14. So in this case, the pOH is what? All you have to do is, again, pH plus pOH equal to 14, okay? Plug this in. 13.30 plus pOH equal to 14. Let's bring this over here. pOH equal to 14 minus 13.30. And you will see that's a very small. And let's plug in a calculator. We have 14 minus 13.30. There you go. And what do we have? Our pH is 0.7. As you can see, this is very basic. Because this is a basic compound. Always, if you have any questions, take a picture of your work, put in the form, and we will do our best to support you. Remember, this type of question are mostly multiple choice question. It's not going to be like problem-solving questions. So start practicing showing your work, because they can change the choice to any type of format they like. And that's why make it more tricky. And we'll see you next time on another exciting chemistry lesson.